Hello everyone, welcome to Physics Ninja. This is the second part of the motion chapter where we will learn about graphs and try to derive the equations of motion. So now we are going to visualize motion through the eyes of mathematics using graphs. So for that, we first need to know some basics of graphs, right? So let me just draw a simple graph. So for drawing a graph, we need two coordinate axes. So this is the x-axis and this is the y-axis. And I'm drawing just a straight curve to keep things simple. So let there be 2 points on the axis, right? And we define these points. I mean the position of these points is defined using coordinates. So let this point be x2 comma y2. We always write the x coordinate first and then the y coordinate. And this point be x1 comma y1. So now what is x1 and y1? So basically y1 is the distance from the x-axis and x1 is the distance from the y-axis. So I hope this is clear. Okay. Similar for this case, x2 is basically the distance from the y-axis and y2 is basically the distance from x-axis, right? Now, if we need to find the slope of this graph, so the slope of the graph will be equal to y2 minus y1 divided by x2 minus x1. As simple as that. And slope is defined as using m. Okay. So y2 is the coordinate of the final point and y1 is the coordinate of the initial point. Similarly, x2 is the x coordinate of the final point and x1 is the x coordinate of the initial point, right? So slope is defined as change in y coordinate divided by change in x coordinate. So with this concept, we'll try to find out the slope of distance time graph. So in distance time graph, always remember when we write distance time graph, so this means that the first quantity will be in the y-axis and the second quantity will be in the x-axis. Similarly, this curve can be called as y-x curve. Okay. Always remember the first quantity is in the y-axis and the second quantity is in the x-axis. So we'll draw a simple curve. Again, to keep things simple, I'll just draw a straight line. Just remember, curves can be very complicated, right? So just to make you understand, I'm drawing the simple curve. So in this axis, we'll write what? Distance, which is denoted by what? D. And in this axis, we'll take time, which is denoted by T, right? And this is in seconds and this is in meters, right? Okay. So now again, let us take 2 points here. So this time, in the first example, we have seen that we have taken y-x axis, right? Now we have changed the name of the axis to distance and time. So obviously this point can be named as T2 comma D2 and this point can be named as T1 comma D1, right? Now, if we need to calculate the slope, so basically one more thing in this concept, so this point can be written as x1 comma 0 and this point can be written as 0 comma y1. Similarly, this point can be written as 0 comma y2 and this point can be written as x2 comma 0. This is how we write coordinates. Okay, so this is very important for you to understand. Similarly, what happens here is that this point can be written as t1 comma 0 and this particular point can be written as 0 comma d1. Again, this particular point can be written as 0 comma d2 and this particular point right here on the time axis can be written as t2 comma 0. So I'm explaining this once. Now every time I make graph, I won't be explaining all these things, right? So please pay attention to this part because this is very important. Coordinates are very important in defining whatever is going on in the graph. Okay. So now if you need to find the slope, what we'll do? So simply it's d2 minus d1 divided by t2 minus t1, right? If you consider time axis as the x-axis and a distance axis as the y-axis, so what we have? y2 minus y1 by x2 minus x1. So here in place of y2, y1, x2, x1, we write d2, d1 and t2, d1, right? Now we can write this slope as m is equal to change in d divided by change in time, right? And if you, I think you have seen this expression somewhere else. Yes, you are right. This is the expression for speed, right? Because speed was what? The rate of change of distance. So what we can state from this graph is that the slope of distance time graph is speed. So this is a very important statement. Okay, the slope of distance time graph is speed. Now let us study about displacement time graphs. So let me just draw a graph real quick. These are the two axes, right? Now on this axis we will have displacement, which is either denoted by x or s, right? So mostly displacement is denoted using s, and this displacement is in meters. And on this axis obviously we have time, which is denoted by t and is written in seconds. So let me just draw a graph which is a bit more complex than the two graphs you have seen earlier. So this graph goes something like this. Okay. Now, if you see a curve which is increasing in this way in the upward direction, always remember that the slope of this curve is positive. Okay. If you see a curve which is directly parallel to the x-axis, then the slope of this kind of curve is 0. And if you see a curve which is decreasing in the downward direction just like this, always remember that the slope of such curves is negative, right? But what is actually the slope of displacement time graph? So let us just calculate it real quick. Slope is equal to x2 minus x1 divided by t2 minus t1, right? Or we can write s2 minus s1 divided by t2 minus t1. So we'll be using these expressions more in the upcoming topics, right? But anyways, we can write m is equal to change in displacement divided by change in time. Now, you have seen this expression before, right? This expression is of velocity, because velocity is the rate of change of displacement, right? So from this entire thing, what we can conclude is that the slope of displacement time graph is velocity. And this is a very important statement. In the earlier slide, we have learned that the slope of distance time graph is speed. And now we have learned that the slope of displacement time graph is velocity. These two statements are very important, and we will be continuously using this concept in the upcoming topics, right? So let us see another interesting thing from this graph. The part for which the slope is positive, in this part, the velocity is also positive. The part for which the slope is 0, the velocity is also 0. The part for which the slope is negative, the velocity is also negative. Now, what does positive, 0 and negative velocity means? So, I have uh, taught you earlier that if the velocity is positive, meaning that the object is moving in a certain direction, let's say right direction, which we consider to be as positive direction, right? So, if the object is moving with some velocity in this direction, then the velocity is considered to be positive. If the object is moving in the opposite direction, then in that case the velocity is negative, which is in this case, right? And if velocity is 0, meaning the object is not in motion at all, right? Because the object is at rest at that time. So I hope you have understood the concept of positive, 0 and negative velocity, and I hope you have understood all the graphs that I have taught here, may it be distance time graph or displacement time graph, because these are very important concepts. And using these concepts, we are going to derive the equations of motion later in this chapter. Now let us try to get on with the numerical. Okay. So the graph which is given in the numerical is basically a displacement time graph. Right? This axis is the time axis, and the y-axis is basically the displacement axis, which is in meter. Right? Now it is given that this point is 100 meter, this is 0, this is obviously 50 seconds, and this will be 100 seconds, right? So this is what the question in the graph looks like. Now it is asked in the question that a girl walks along a straight path to drop a letter in the letterbox and comes back to her initial position. So we don't need to focus much on this statement. The only thing that matters in this question is the graph. Okay, her displacement time graph is shown in the figure as I have drawn here. What is her velocity between 0 to 50 seconds and 50 to 100 seconds? Okay, so before finding the velocity, what we will do is that we'll first write the coordinates of each and every point in this graph. So this will make our numerical much easier. Okay, so we know that if we need to write the coordinate, first we write the x value and then the y value, right? So x value comes first and then the y value. So in this point, this is known as the origin, right? There is no x value and y value, so both the values will be 0, 0, right? Now at this particular point, since it lies on this particular axis, time axis, or you can say x axis, so we'll have only the x value and the y value will be 0. In this point, we'll have 100, 0 because it is like the same case as this 50 seconds. It lies on the x axis, so it will have only the x component and the y component will be 0. But this point here has both x and y components. So what will be the y component here? Y component will be what? 100 meter. And what will be the x component? X component will be 50 seconds. So the coordinate will be 50, 100. Right? Now we are all set to do this question. So let us see now what the question has asked. We need to find the velocity between 0 to 50 seconds. Means we need to find the velocity in this part, right? So we know that in displacement time graph, the velocity is nothing but the slope of the curve, right? So we simply need to find the slope. So what does the slope of displacement time graph says? That it's s2 minus s1 divided by t2 minus t1. So don't get confused with s2 and s1. s2 is basically the final position, s1 is the initial position, t2 is the time taken to reach the final position, and t1 is from where the girl has started, right? So in this case, the girl started from this point and has reached this point, right? So what we can write is that this 100 will be s2 and this will be s1, right? This is the final position, this is the initial position. Similarly, this is the final time and this is the initial time, right? Now we can easily find the velocity. So put the values: 100 minus 0 divided by 50 minus 0, which is equal to what? 2 meter per second. See, as I told you, if you write the coordinates, this type of numericals become much easier, right? Now let us find the velocity during 50 to 100 seconds. So the velocity, which is equal to the slope, is equal to again s2 minus s1 divided by t2 minus t1, right? Now don't get confused with s2 and s1, right? You might think that this will be s2 and this is and the s2 and t2 will be fixed for this coordinate. No, it is not like that. S2 basically means the final position and S1 is the initial position. Similarly, T2 is the time taken to reach the final position and T1 is the time from where the color started, right? Now, this journey is started from here, right? And the curve goes all the way and reaches at this point. So, here S2 will be this, right? And S1 will be this, because this is from initially where the girl started and this is where she reached, right? So similarly, this will be T2 and this will be T1. As I told you, writing the coordinates makes the numerical much easier. So just put the values again. S2 is 0, S1 is 100, T2 is 100 and T1 is 50. So we basically get minus 100 divided by 50, which is equal to minus 2 meter per second. And I have explained you before that if the velocity is positive, means someone is moving in this direction or any direction which you consider as positive, and if the velocity is negative, meaning that they are moving in the opposite direction, right? So I hope you have understood this numerical and also have understood the concept of slope and distance and displacement time graphs. Okay, this kind of numericals is expected in the examination. Now, let us move on to visualizing motion using graphs, and this time we'll be using speed time graph and velocity time graph, right? So how do you visualize motion using speed time graph? Let me draw a simple graph again. So this is a very simple curve. Okay, this time this will be the speed axis, which is in what? Meter per second, and this is the time axis, which is obviously seconds. So I'll draw a very simple curve and I'll just join this curve with dotted lines. Now the important thing to note is that if you can find the area under this curve, right, this area under this curve will give you distance. Yes, you heard me right. So this is a very important key point, that the area under speed time graph is distance, right? Okay, and always remember the slope of a speed time graph is always positive. The reason being, both the distance and speed are scalar quantities, so they can't be negative, right? They only have magnitude. Now let us see the velocity time graph. So let me just make it a bit more complicated. Let's just make the same graph which we have made earlier for displacement time graph. Okay, so this is how the curve goes. This time, this is the time axis, which is in seconds, and this is the velocity, which is in meter per second, right? Now, I told you earlier, if you see a slope which is increasing in the upward direction, so always remember that this slope is positive. In this case, if the curve is parallel to the x-axis or the time axis in this case, the slope is 0. And if you see a slope which is going downwards in this way, so remember that the slope is negative. Okay, but what is actually the slope of velocity time graph? Let us quickly find out. So the slope is what? V2 minus V1 divided by T2 minus T1, right? Which we can, V2 is basically what? The final velocity, which we can write as V, and V1 is what? The initial velocity, which we can write as U. So this can be written as what? Del V by del T. And you have seen this expression before. Yes, right. This is the expression for acceleration, right? So what we can simply write here is that the slope of velocity time graph is acceleration, right? Okay. Another important thing is that if you can calculate the area under this curve, the area under this curve will give you displacement. Just as in case of speed, which gives you the distance, so we can write this that the area under velocity time graph is displacement, right? Okay, so we can find out some more information from this graph. Okay, this graph is very important actually. So let's see what else we can find out. So if the slope is positive, meaning the slope of this velocity time graph is what? Acceleration, meaning the acceleration is also positive. And if acceleration is positive, we know that velocity is increasing. If the slope is 0, meaning the acceleration is 0, which means that velocity is constant. If the slope is negative, meaning the acceleration is also negative and the velocity is decreasing, right? So all this we have studied earlier also, but this is how we can use all of these concepts while looking at a graph. Okay, now important point to note is that in some numericals you will find that it is given that the slope of speed time graph is also acceleration, right? Let me just write this in some numericals. Slope of speed time graph is acceleration, but it is not completely true, because see, acceleration is the slope of velocity time graph, because acceleration is a vector quantity and so is velocity. But when you see the graph of speed and time, okay, there is no vector quantity at all, it is only scalar. So how acceleration can be the slope of the speed time graph? But the thing is, when we do numericals, right, this velocity and speed, they are used interchangeably. Okay, so in some numericals you may find that the slope of speed time graph is also given as acceleration. So don't consider it wrong, just go along the way, right? If you see that the slope is given as acceleration, so just do the numerical in that way. But technically it is wrong, because the slope of velocity time graph is only acceleration. So I hope you have understood, because there was a ton of information in this slide. So we'll try to understand these concepts more with the help of a numerical. So the numerical tells us the velocity time graph, shows the motion of a cyclist. Okay, so I'll just draw the graph for you first. So just remember, it is a velocity time graph, right? So here we have velocity, and on this axis we have time. Okay, now I'll draw the graph. So we have 25 here. So velocity will be in meter per second, right? And time will be in seconds. So we have 25, 20, 15, 10, and 5. And we have 0. And similarly, we'll have 5, 10, 15, 20, 25. And the graph is something like a straight line which is parallel to the time axis, right? So this is the graph that is given in the question. Now we are asked that to find its acceleration. So we know that acceleration is what? Acceleration is basically the slope of velocity time graph, right? Now we can see that the curve given is a straight line which is parallel to the time axis or the x-axis. And as I have shown you in the previous slide, if you have a curve which is parallel to the time axis, there the slope is what? 0, meaning that the acceleration is 0, right? We know that if acceleration is 0, meaning the velocity is constant, So in the next point, we're asked to find this velocity. So the velocity is obviously what? 20 meter per second, because it is going at a constant rate. So velocity is what? 20 meter per second. Now it is asked to find the displacement by the cyclist in 15 seconds. Now what we know is that displacement is the area under the velocity time graph. So we need to find the area under the velocity time graph to find displacement, right? So it is asked to find the displacement in the first 15 seconds only. So what we'll do is that in this 15 seconds, we'll just draw a line. Let's say 15 seconds, and we need to find this particular area, right? So if you say this particular part is a rectangle, right? This is a rectangle whose length is what? 15, and whose breadth is what? 20, right? Whose breadth is 20, because we're going all the way up to 20 here, and we're going all the way up to 15 here. So the length is 15, and breadth is 20. So what will be the displacement? Displacement will be directly the area, which is equal to length into breadth, which is equal to 15 into 20, which is nothing but 300 meter, right? So this is the displacement by the cyclist in 15 seconds. So I hope I am able to use all the concepts that I have taught in this single numerical, and I hope you have understood it as well. So now we'll try to learn about the equations of motion. We're going to derive each and every equation of motion using the graphical method. Okay. So for the first equation of motion, we'll use a velocity time graph. So velocity in the y-axis, which is in meter per second, and time in the x-axis, which is in seconds, right? This point is given as u. This particular point is given as v, which is basically the final velocity and the initial velocity, and this is t, right? Now what I told you earlier is that if you are given a graph, try to write its coordinates, so it will make solving it easier. Okay, so we'll try to write the coordinates of this graph. So basically the coordinate of this particular point is what? 0 comma u, since it lies on y-axis and there is no x coordinate, so it will be 0 comma u. And what will be the coordinate of this particular point? It will be t comma b, right? Because t is the value for the y coordinate and b is the value for the t is the value for the x coordinate and b is the value for the y coordinate. So the coordinate will be t comma v, right? Now we just simply need to find the acceleration. We know that the slope of velocity time graph is acceleration, right? So simply we just need to find the slope. In this case, this is y2, this is x2, and this is y1, this is x1. We know that slope can be calculated as y2 minus y1 divided by x2 minus x1. And we know that the slope of VT graph is acceleration, so we can write acceleration, or which we denote it with A, is equal to y2 is what here? V. Y1 is what? U. X2 is what? T. X1 is what? 0. So we can write acceleration is A is equal to V minus U divided by T. We just need to rearrange it now. So if we just take T to this other side and multiply it with A, we get AT is equal to V minus U. And we take U to the other side, and we can write it as V is equal to U plus AT. So this here is your first equation of motion. Just remember this equation of motion because it is very useful and it will be used in most of the numericals, right? Okay, so moving on to the second equation of motion. So we'll have this same graph, okay, and it will be the same velocity time graph. So here we have velocity and here we have time, right? This point is u, this point is v, and this point is t, right? Okay, so for this graph we'll try to find the sides also. So let's say if this point is v and this point is u, then this entire length will be what? V minus u, right? And if this let's consider the x-axis only. If this is 0 and this is t, then this entire length is t, and so also this length will also be equal to t, right? Now we have all the required values, and so what will be this part? That this part is 0, this part is u, so this part will all the length of this part will be equal to u, right? So now we have all the sides of this diagram. And why have I firstly calculated all the sides? I will explain you now. Okay. So for the second equation of motion is about displacement. Fine. And we know that the area under VT curve is displacement. Meaning that to find the displacement, we need to find the area under this entire curve, right? Now how do you find it? So let me just break it down for you. Okay, displacement is generally denoted using S. So S can be written as, firstly we have this part, right? We have this triangle part. So we know the area of a triangle is what? Half into base into height. In this case, what is the base? The base is t, right? And what is the height? The height is what? V minus u. Now I hope you are getting to understand that why have I written all the sides, right? Next, we need to find the area of this rectangle, right? The area of this rectangle is what? Length into breadth. So what is the length here? T. And what is the breadth here? U. So we have found out the area of this triangle and this rectangle. Now what we can do is that we need to find the total area. So what do? We add it up simply. So S will be what? T into U, the area of the rectangle, plus half into T into V minus U. So we can just rearrange this. Okay, so we can write S is equal to U T plus half into V minus U into T. Right? I have just rearranged everything. Now, from the first equation of motion, what we have? We have V is equal to U plus AT. Right? If we take U to the other side, what we can write is that V minus U is equal to AT. And T is what? We don't need to calculate T. Okay, let's just leave T for this bit. So what we found here is V minus U is equal to AT. Now, if we put the value of V minus U with AT, right, what you get is that S is equal to UT plus half into, in place of V minus U, what we put is AT into T. So we get is S is equal to UT plus half A, and T into T means T square. So here is your second equation of motion. Right? I hope you have understood this. So let us now move to the third equation of motion. For the third equation of motion, we have the same velocity time graph. So we have this velocity time graph, right? This is again U, this is again V, and this is T. Now, again, in this case also, what we'll try to find is the area under the curve, which is basically displacement, right? Displacement is the area under the curve. Now, earlier what we have used, that we have summed up the area of this triangle and this rectangle, right? But in this case, for the third equation of motion, we'll not just sum up the area of the triangle and the rectangle. What we'll do is that we'll find the area of this particular trapezium. If you see nicely, this shape is the shape of a trapezium, right? So we need to find this entire area. What is the area of a trapezium? Area of a trapezium is half into sum of parallel sides into height, right? Now, I'll just erase this part. You have understood about the trapezium, right? This part is the trapezium. So this two are the parallel sides, right? So this parallel side has what? Starting from 0 to U, we have this length of the parallel side as U, and the length of this entire side is what? V, right? The length of the entire side is V here. And what is the height? Height is basically this dotted line. So we know that from this part to this part we have a distance of T. So obviously this part will also be equal to T, right? So we can find the area of this entire trapezium, and this will be equal to what? The displacement, which is S. So S will be equal to what? Half into sum of parallel side, which is what? U plus V into height, which is what? T. Right? Now again, what we can write from the first equation of motion is that v is equal to u plus at, right? So if you bring u to this side, so we have v minus u is equal to at, and so t is equal to v minus u divided by a. Now if we replace this value of t here, what do we get? So what we get is that s is equal to half into u plus v into v minus u divided by a. Rearranging it, what we can write, s is equal to v plus u into v minus u divided by twice a. So u plus v I have written in form of v plus u. So we know that a plus b, a into a minus b is what? A square minus b square. So it will be v square minus u square divided by twice a. So if we take twice a to this side, we can write 2as is equal to v square minus u square. Rearranging it, we can write v square minus u square is equal to twice as, and this is your third equation of motion, right? These three equations of motions are the most important thing in this chapter, and we'll be doing some numericals so that you can understand how to use this formula in a better way, right? So let us dive into our first numerical, which says that a lead bullet of mass 0.1 kg is traveling with a velocity of 20 meter per second, comes to rest after penetrating 20 meter in a steel target, meaning that initially it was traveling with 20 meter per second. So this is the value of u, and it comes to rest means finally it comes to rest, meaning the final velocity will be 0, right? After penetrating 20 meter in a steel target. So this 20 meter is basically what? The displacement. Here it is asked that find the average velocity, average acceleration of the bullet, right? We need to find the average acceleration. So now we have three equations of motion. So we have v is equal to u plus at. We have s is equal to ut plus half at square. And we have v square minus u square is equal to twice as. Now the question is, which of this equation of motion is to be used for solving this problem? Now this depends on what values are given in the question. So if we, let's say we want to use the first equation, right? We'll see that we have v in the question, we have u in the question. We need to find acceleration, which is in the question, but we don't have time. We don't have the value of t, right? So this equation of motion cannot be used. Let's check out the second one then. So we have displacement, which is given in the question, so it is okay. We have the initial velocity, but there was no time given again. We need to find acceleration, and again we have this time component which is not given, so we cannot use this equation as well. We are left with only the third option, which is the correct option, right? So let us see how we use this. So the third equation is v square minus u square is equal to twice as. Now what the value of v is what? 0. So we'll write 0 square minus the value of u is what? 20. So we'll write 20 square is equal to 2 into a into what is the value of s? This is 20 meter, right? Okay. So 0 square is 0 minus 20 is what? 400 is equal to 2 into a into 20. So we can write a is equal to minus 400 divided by 2 into 20, which is nothing but 40. So minus 400 divided by 40, which is equal to minus 10 meter per second square. You see here the acceleration is negative, which means that velocity is decreasing. And if you see the question, that is exactly the case. Velocity is decreasing, meaning that the final velocity is lesser than the initial velocity, which is exactly the case. The final velocity is 0, but the initial velocity was 20, meaning that velocity is decreasing. So we are asked to find the acceleration. So the answer is the acceleration is what? Minus 10 meter per second square. Also, one more important thing, there is a specific name given to negative acceleration. So acceleration, negative acceleration is also called retardation. So just remember this name, okay? If you see this name somewhere, retardation, just remember that it means negative acceleration, okay? Let us try to solve another numerical now. So it says a train is traveling at a speed of 90 kmph. It means 90 kilometer per hour. Okay, so this is basically the initial velocity. Brakes are applied so as to produce a uniform acceleration of minus 0.5 meter per second square, which means that it is talking about retardation, because we know that negative acceleration is called as retardation, right? And if the acceleration is negative, meaning that velocity is decreasing, right? Which is very obvious, because if the brakes are applied, the train will come to a halt, so the final velocity will be 0, right? So let's say now we have the initial velocity to be 90 kilometer per hour. Now, as I told you that always check for SI units, right? This kilometer per hour is the most widely used unit, but it is not the SI unit. So as I told you, always before solving any numerical, convert every physical quantity into its SI units. Okay, so 90 kilometer per hour can be written as 90 into 1 kilometer divided by 1 hour. This kilometer needs to be converted into meter, and this hour needs to be converted into seconds. So we can write 90 into 1 kilometer means what? 1000 meter divided by 1 hour means what? 60 into 60 seconds. So this will be nothing but 90,000 meter divided by 3600 seconds, right? Which is equal to 25 meter per second. Now we have U is what? 25 meter per second. V is 0 meter per second. A is minus 0.5 meter per second square. Now the question is, how far the train will go before it's brought to rest? So we need to find what? The displacement S, right? Again, let me write the three equations of motion. We have V is equal to U plus AT. We have S is equal to UT plus half AT square. And we have V square minus U square is equal to twice AS. Again, you can see there is no component of time given here. So the first two equation gets cancelled out. We'll only use the last equation now. So we have V square minus U square is equal to twice AS, right? S is the displacement. So V is what? 0 square minus U is what? 25 square is equal to 2 into acceleration is what? Minus 0.5 into S. So we can find the displacement from this equation now. So it will be what? 0 minus 625 is equal to minus 1 into S. So the displacement will come out to what? 625 meter, which is the correct answer. So I hope you are now clear with the fact that how to choose which equation should we use for a numerical, right? Always check for the quantities that are given in the question. We'll solve a last question, which is a ball is gently dropped from a height of 20 meters. So basically this is the displacement. If its velocity increases uniformly at the rate of 10 meter per second square, 10 meter per second, always check for units. So it's meter per second square, meaning that its acceleration. what will be the velocity, with what velocity will it strike the ground? After what time will it strike the ground? So there are two questions. So with what velocity will it strike the ground, and after what time will it strike the ground? So we have to find two quantities, that is v and t, right? So it is said that a ball is gently dropped from a height of 20 meters. So the initial velocity of the ball is what? 0, because it is dropped from rest, right? We need to find v and t. Again, I will write the three equations of motion. We have v is equal to u plus at. We have s is equal to ut plus half at square. And we have v square minus u square is equal to twice as. Now think carefully, which equations are you going to use? The first thing is that we need to find two variables, right? So obviously we'll need two equations, right? Okay, so for two equation, what we do is that we don't need this particular equation now, because yeah, we can also use this particular equation, but it will be a quadratic equation and will be quite complicated to solve. So let us just skip for this equation for a bit, and let's just focus on v is equal to u plus at. We need to find v, right? So v is equal to u, we have 0, plus a is what? 10 meter per second square, but the ball is falling what? From the ball is falling downwards, right? So always remember, if the acceleration is downward direction, we'll consider the acceleration to be negative. If acceleration is in upward direction, the acceleration is considered to be positive. If acceleration is in this direction, it is positive, and acceleration is in this direction is negative. Okay, so since it is falling down, so will consider the acceleration to be minus 10, right? So we'll write minus 10 into t. We don't even know what t is. So v will be what? Minus 10t. So we have this first equation, right? Let us use this equation again, where we have v square minus u square is equal to twice as. So v is basically, we don't know what v is, minus u square, u is 0, is equal to 2 into minus 10 into s, right? And we know the value of s. Oh, also we can put the value of v from equation 1. So we can write 10t whole square, which is equal to 2 into minus 10 into s. S is what? S is basically 20 meter, right? So here we can find as 100 t square is equal to, one more important thing to note is that the displacement is also in the downward direction, right? So s will not be simply 20 meter, s will be what? Minus 20 meter. This is the same case as that of acceleration. Okay, so I'll clear it once again. So if you have velocity, acceleration, or displacement in this direction, it will be considered as positive. If you have velocity, displacement, and acceleration in this direction, it will be negative. If you have velocity, acceleration, and displacement in this direction, it will be positive. And if you have velocity, acceleration, and displacement in the downward direction, it will be negative. So here the displacement is also in negative downward direction, and the acceleration is also in downward direction. So both will be negative, right? So here in place of 20, what we'll write as minus 20, right? So here we have 100 t square, which is equal to 2 into minus is plus, so 2 into 10 into 20 simply, right? So it will be 100 t square is equal to 400. Am I right? Yes. So t square will be equal to what? 400 divided by 100, which is equal to 4. And t will be equal to what? Plus minus root over 4, or t is equal to plus minus 2 seconds. So anything which comes out of the square root always have two values. One is plus, one is minus. Now we know that time cannot be negative, right? Time can never be negative. So what we'll consider is that t is equal to 2 seconds. So here we have one of our answers, t is equal to 2 seconds. So this answer will be t is equal to 2 seconds, right? Now for the second part, what we do is that v is equal to minus 10 into, we put the value of t, which is what, 2 seconds. So v is equal to what, minus 20 meter per second. So here we have our second answer, which is minus 20 meter per second. Always remember that this negative sign shows us that direction is downwards, right? As I told you in this concept, in this case, the acceleration, displacement and velocity all are in the downward direction, and so they have a minus sign, right? Because they all are vector quantities. So now we have come to an end of this chapter. So I hope you have understood the entire chapter, and I will try to conclude this chapter with some important key points. So the first key point is that an object is said to be rest if its position does not change with time and with respect to the observer, and it is said to be in motion when its position changes with time and with respect to the observer, right? Rest and motion both are relative concepts, as we have seen from that example of train, which means that they depend on the reference point and the frame of reference. Scalar quantities are the quantities which has only magnitude, like speed and distance, and vector quantities are the quantities with both magnitude and direction, like velocity and displacement. The complete path length between 2 points is called distance, and the shortest distance between the final and initial point is called displacement. Speed is basically the rate of change of distance, and velocity is the rate of change of displacement. Acceleration is the rate of change of velocity, but as I have told you, in some numericals, you will also be able to see that acceleration is the rate of change of speed as well. The slope of distance time graph is speed, and the slope of displacement time graph is velocity. The slope of velocity time graph is acceleration, and the area under the velocity time graph is what? Displacement. And also the area under the speed time graph gives us distance. Also, the three equations of motion, which are the most important equations in this entire chapter, is v is equal to u plus at, s is equal to ut plus half at square, and v square minus u square is equal to twice as, where v is the final velocity, u is the initial velocity, a is the acceleration, t is the time, and s is the displacement. So I hope you have enjoyed this lecture. I hope you have learned some of the most important concepts in physics. If there is any doubt, please do let me know in the comment section. And thank you so much. We'll meet you in the next chapter.